Pranav. Pranav, good
Hi, sir.
evening.
Good evening,
Hi.
sir.
Yeah.
Hi.
Amit, good evening. Amit is also joined.
Yeah,
Yeah.
Good evening.
Shall we start? Yeah. Good evening. Good evening. And welcome. Shall we start?
yeah,
People will
we
go
are
on
ready to go.
joining. Yeah. Yeah. We are ready to go. Renuka ma'am.
Yes, sir. Very good evening to all. I, Renuka Pawar, wholeheartedly welcome you all on behalf of the organizing committee at Bharati Vidya Bhavan's Sardar Patel Institute of Technology on the seventh day of AICT sponsored 2-week faculty development program on data science and application. So today we have two experts for the session for the topic data science and machine learning with MATLAB. So we have with us Mr. Amit Kamath. So I take this privilege to warmly welcome Mr. Amit Kamath. Amit is an education technical evangelist at MathWorks and works with the academic institution in India on the adoption of MathWorks workflow in the curriculum and research. Amit has been with the MathWorks for 7 years and has previously worked with engineering development group and software development in the image processing and computer vision areas, focusing on workflows for image registration and pixel labeling. His areas of interest include computer vision, software engineering. Amit has a bachelor degree in electrical engineering from NITK Surantakal and a master degree in electrical engineering from the University of Minnesota. Now, I take this privilege to welcome our next speaker on board, that is Pranav Lad. He is also from the MathWorks. So, Pranav Lad is an education technical evangelist at MathWorks, based out of Pune. He work closely with the academic institution in order to help accelerate the piece of research and learning outcome. His technical expertise lies in the field of vibrations, nonlinear dynamics, and machine learning. He has authored various research papers in international journal and conference proceeding. He has previously worked as a research assistant at IIT Bombay, wherein he interacted with various industries for consultation. He is about to finish his doctorate in mechanical engineering from the Indian Institute of Technology Bombay. Prior to that, he had received his bachelor degree from University of Pune. So I welcome both of you, sir. So may I request you can to hand over the session and you can start with the topic.
Sure. Thank you, ma'am, for the warm introduction. Uh, can you make me the presenter so that I can share my screen? Yeah. Please let me know if my screen is visible.
Yes, sir, it's visible.
Yes, it is.
Sure. Thank you. Thanks once again for the introduction and welcome all to this particular session on data science and machine learning with MATLAB. I'm Pranav Lad, and with me is Amit Kamath, uh, and also several other math workers who have helped us in building this content over here. So, just a quick sort of agenda here. How are we going to proceed? The first 50 minutes, we are sort of take this opportunity to set up the stage, and we'll move on to, or we'll discuss two of the important demos on exploring different data sets. We'll go over that, and we'll go over the basic curve fitting, particularly using MATLAB in this particular case, in this session. Then we'll have a short break, and after that, we will actually dwell into machine learning. And in machine learning, particularly, we'll talk more on classification. We'll give you the overview of other things as well, but mainly we'll spend some time on classification uh, with one of the demos. We'll discuss more on how different algorithms behave with the machine in the classification, that particular demo that we are going to see. And then, if time permits, we'll also talk about how to work with big data, particularly using MATLAB. And after that, we can have some open-ended question answer sessions. We can have some time for discussion as well. Uh, but again, in between as well, if you have any questions or if you want to ask something, or if you want to make some things clear, you can either raise your hand or you can post that in the chat window. Amit is also with me, so he'll be continuously monitoring the chat window and Q&A window. So you can sort of take a look at that and clear out a few of the queries right at that particular point. So let's get started. Uh, as as we said, me and Amit are from MathWorks. So MathWorks is basically the company which created MATLAB and Simulink. So MATLAB and Simulink are the two flagship products of MathWorks. And the key motivation here is key goal of the MathWorks company is to accelerate the pace of engineering and science. So particularly both of us and other colleagues and our team particularly works with academicians to help them accelerate the pace of learning in the students and also accelerate the pace of research work that they're doing in their particular universities with the use of the software product that we have that is known as MATLAB. What is MATLAB? So MATLAB is a programming environment for algorithm development, data analysis, visualization, numeric computation, and so on. So basically, it's a high-level programming language, very and particularly targeted towards engineers and scientists. Using this, we can analyze different types of data and perform many other things as well. Another product is Simulink. So how it is different from MATLAB is MATLAB was a programming based environment. Simulink is a graphical environment, or it is based on a block diagram it is a block diagram based environment. So engineers are particularly more interested in doing things in terms of block diagrams. So since this is particular, I mean, so this particular environment attracts engineers a lot, and especially when we are dealing with dynamic systems. So the Simulink can help in designing, simulating, and testing dynamic systems using block diagram based environment. So apart from these two flagship products of MATLAB and Simulink, there are multiple, nearly hundreds add-on products that we have which perform specialized tasks. These are also available and which we can use along with MATLAB inside MATLAB. Just to give an example, this is a computer vision system toolbox that we have that can be accessed through MATLAB and can perform many other complex tasks as well. So uh, if so I know there are faculties from all over India and from different institutes. So if your particular institute has campus-wide license of MATLAB, you have access to multiple other things as well. What benefits you will have is you can install MATLAB and all other products in the university and lab computers. Also on your personal computers, you have unlimited access of that. You have unlimited access for online access and self-paced online training programs which are there. You also get an access to cloud storage platform known as ThinkSpeak, which is again a MathWorks product. And you can so basically you'll get number of advantages if the your university has campus-wide license. Some of you already might have known about this. Uh, Especially this particular tool known as auto-graded homework. The tool is known as MATLAB Grader. It's also useful in this particular scenario where we all are working from home, where you can create your assignments and exams using this tool. You can conduct this, and it will help you to automatically grade those things. So basically, if the university has campus-wide license, you'll have access to all of this. So if you want to know whether your university has campus-wide license or not, you can let us know. Or if you do not have the campus-wide license, you can get in touch with us, and we can probably help you in that particular sense. But now, so moving onto our main topic today on data science. But before data science and machine learning, why computational thinking itself is important. So what is computational thinking? Computational thinking is where we sort of learn to code and also code to learn. So why learn to code? So this is a course. This is a quote from one of the vice president of Microsoft Research. So uh, it's like computational thinking is fundamental skill for everyone, not just for computer scientists. As you saw, I'm particularly a mechanical engineer, and I'm not from the computer science background. But I can and all of you will agree that nowadays, maybe a mechanical engineer, electrical engineer, or any other engineer for that matter, the coding or the computational thinking is as important as it is for a computer scientist in this current field. And also code to learn, because when we code, we get into think in a logical way. So this is a quote by one of the student from MIT, USA. So nowadays, particularly interdisciplinary approaches are coming in. Interdisciplinary science is going up, and for that thing, to build our successful careers, we need to have computational thinking imbibed with us, and we need to work on that as well. So with this small sort of introduction, if your university has campus-wide license, I'll request not right now, but you can I'll request that you can go to MathWorks page and create your MathWorks email ID. Sorry, MathWorks account using your educational university's email ID. That will give you access to a lot of other things as well. Uh, Particularly, you can access MATLAB or through online. You can have access to MATLAB Drive and all other online course pages as well. Okay, so now getting into our main topic of data analytics. So why data analytics or machine learning or say artificial intelligence? We know all these terms are getting I mean getting a lot of weightage in these days. These are all becoming very fancy words nowadays. Why? I mean, if you really look into these sort of terminologies, or if you really look what goes what goes at the back end of these is nothing but the statistics or mathematical operations, right? So we knew like statistics from very early days, and we from maybe 100, 200 years ago, we already know what statistics was. But now these terms are getting more importance nowadays because we now have access to a lot of data. Earlier, we did not have a lot of access to data. Nowadays, we have because of various other advances in technology, and that's why the methods that were developed earlier in the statistics or mathematics, those are gaining a lot of importance to solve different problems using the data that we have right now. If you look at where data analytics is gaining importance, is actually gaining importance in a lot of, almost all the fields, may it be aeronautics, automotive, industrial automation, clean energy, medical devices, railway systems, and all of this, as well as in many service industry as well, may it be retail industry, finance industry, healthcare management, internet, and all these things as well. So if you look into technical aspects of it, these are the terms that are closely related, or these are the areas in which data analytics is gaining more importance, like condition monitoring, process analytics, health monitoring or a risk analysis, supply chain, and all these things, right? Uh, so what is data analytics particularly? It is it is a method to turn large volumes of complex data into actionable information. So if we have a lot of data, what can we do with that data so that we can finally make some decisions out of it, right? So what all can we do? We can maybe do some descriptive type of analysis. So we have some type of data with us, and we can look at that data, analyze the data, and see what happened, what exactly happened based on whatever data we have. So this is a description. We are just explaining or giving a description of the event that has happened based on some of the data. Other thing is diagnostics. So once something has happened, based on the data and analysis that we make, uh, we can probably make some decisions on why did it happen. I mean, so initially we saw what happened, now why did it happen? And based on, again, that the data that we have, maybe we can also comment on something on what will happen, right? So this is a predictive type of analysis that we can do. And another one is prescriptive. So based on the data analysis, again, we can work on and come up with the decisions on what should be done in one particular context or in one particular problem, right? So all these decision making problems that can be handled if we have some amount of data and we perform some kind of analysis on that particular data, right? So doing some analysis on the available data and turning that analysis into some kind of useful decision making process, that is known as data analytics, right? So what is the workflow of data analytics? What do we mean? What do we mean by workflow? Workflow is so how I mean, yeah, we now know what data analytics is, but how to go with that, right? So first important step is we need to have access to that particular data, right? So we need to have access to data. Data can be of many form. It can be in the form of a lot of files. We can have a lot of data which is stored in the databases. And particularly in engineering applications, now we have access to data through various sensors which are developed by engineers, right? So those could be accelerometers, gyroscopes, or thermocouples, or whatever. I mean, all sorts of sensors that you are aware of. So we need to have access to all this, the required data that we want, on which we want to perform data analytics, right? So that's the first step. Second step is once we have access to data, we need to pre-process that data because data can be really messy, right? Data can have a lot of noise in it, or so that we need to deal with that particular noise. Then we need to basically what we need to do is we need to extract some useful information out of that particular data. I mean, we can have access to a lot of data, but maybe not all the data is important to us, right? So we need to pre-process that data. We need to extract some useful information out of that, and that is known as a feature extraction from the available data. So all this comes into pre-processing of the data. So first is accessing the data, pre-processing the data, and once we pre-process data, based on the data that we have after pre-processing step, based on that data we will develop some kind of models out of it, right? So those could be machine learning models, those could be deep learning models, or even basic data science models. Those models will be built based on whatever data we have after the step of pre-processing, right? And then once these models are validated, once we have created our own model based on the data, final step is to use that model at a higher level, maybe in terms of desktop apps, or in terms of you may want to deploy this model into the actual hardware, where this hardware will finally work in the field, and it will use your model that you have developed and to make some predictions based on, say, machine learning or deep learning and so on, right? So these four steps essentially constitute the data analytics workflow, right? So let's look at the first, like accessing and exploring the data and pre-processing the data. What comes in it? What type of data we can have? We can have data from multiple repositories. We can have data from web sources. We can have engineering and scientific data from different sensors. and so on, right? And so now we need to make use of this data. So what are the challenges? What sort of challenges we can have? The first important challenge that we might have is data can be of different types. So, I mean, it can be of, say, images, it can be of text form, audio form, etc. It can be of any form, also from different sources. Also, those might be poorly formatted, particularly if those are from, say, engineering data. Then it can have some other challenges associated with that particular data as well, right? So we need to have something to deal with all those challenges, and that's where MATLAB can help you in that particular sense. So MATLAB provides point-and-click tools to access variety of data sources. So you can deal with almost all the data sources, all the data types with using MATLAB. Uh, and it gives you the high performance environment for big data. uh, Particularly, it gives you access to built-in algorithms for data processing, particularly of engineering data sets, uh, using which include the sensor, image, audio, video data, and all that, right? So uh, to yeah, so MATLAB so basically it takes care of all these challenges that we discussed in the previous slide, right? So to get started, what I will do is we will go through this one, the first demo on the exploratory data analysis, where we will what we'll do is we'll go through one of the problem and try to see how we can explore data even before going into the model building stage. Just whatever data we have, how we can explore that data in MATLAB, and maybe get some idea, some basic idea of on which we can then build models further, right? So what tasks we'll perform? We'll work with tables in MATLAB and understand how they represent data. We'll do some sort of exploratory data analysis using some simple statistics function, and try to do some feature engineering and so on, right? So before I mean let me directly go into MATLAB and show you. So uh, uh, I hope I'm not sure, but if people are new to MATLAB itself, and this is how the MATLAB looks like. We have command window over here. We have workspace wherein you'll have all the variables stored that you're using and creating and so on. I'll come to all other things as well one by one. Uh, but now let's go and look at this particular problem that we are going to discuss on exploring data sets, right? So this particular environment is called as a live script of the MATLAB, wherein you can add your text, you can add hyperlinks, even images over here. You can also add your code in the same platform, right? So this particularly helps if you're a faculty and trying to teach some of the concepts to students. The one-stop platform can help, such as this live editor over here, and also to students if they're sort of doing working on some coding projects and finally compile their report. This platform actually really helps them. So the demo that we're going to look at is we are going to explore the data of the Titanic ship that had undergone some accident. We all know that, right? Uh, so this data set is available in this particular link. So after the session, I will share all these demo files and the slides, the presentation slides with the organizers from which you all can get an access to, and then after that you can all go through these demos on your own as well, and you can try multiple things with the demos that we're going to show right now, right? So this data can be accessed through this particular link. We have a data of the passengers which were on board on the Titanic, and we have a data for the passengers who have survived out of that accident and who have not survived out of that particular accident, right? And this particular data is if I go back into the workspace, this particular data is stored in this train.csv and test.csv. So I'm sure all of you, I mean, this FDP is going on. I think this is the sixth, seventh day of the FDP, and you sort of know what training and testing means in this context. But so just to give an idea, so before doing any sort of machine learning or a deep learning type of model building activity, what we do is whatever data we have, we split that data into two parts, a training part and a testing part. We build our model based on training data set that we have, and then we use that particular model uh, uh, and check the test data and see whether how better our model works and so on, right? So this is a train.csv file that we have in the that we have with us. So note that the extension is .csv. So this is a CSV type of data file that we are working with. I am running this particular code, which is sort of loading this particular data set into MATLAB. And so this is a read table command where it reads a table format of the data. And this particular line will show a first few rows out of it. So let's see what type of data we have. So this is the type of data that we have with us, right? So easily we can look at the top row where it sort of suggests what is there in that particular column. So we can see here approximately, I think there is, yeah, so if you look at here, 8 cross 12 table. So there are around 12 columns which are there of this in this particular data, in this particular table, right? So there's 12 columns essentially in terms in the data science or the machine learning world, we call them the feature or predictors, right? Predictor or response, all these columns which are there. Right. Now, let's try to look at what are the variable names over here in the first line or the titles of the columns, right? So that's this we can this we can access using this. So train was our table. So train dot properties dot variable names will give you all the variable names which are there for the 12 columns, right? So if the data is recorded in a systematic way, just by looking at the variable names itself, we sort of get a lot of insights into the data that we have. So we have 12 columns. We have these the names of those all columns. Possibly we can identify, say the name, sex, age, ticket, fare. These are quite a good names, and we get some insights like, okay, the which one is this? So this is one, two, three. Column is uh, uh, fourth column has names of the passengers. Fifth column has sex, the male or female of the passengers, and the age is there in the next column, and so on, right? But there are few titles like this SIB SP. We don't know what it is. Probably if we so I mean, we don't know what this title is not so good, right? Maybe if we know about that and we want to change this particular title, we can do that as well. So we are sort of finding, so in this particular line of code, we are finding what is the index of this particular title in the table, and we are replacing this title using number of siblings and spouses, right? So this gives us more sort of intuitive understanding of what is there inside that particular data set, right? So all these things we can do. We can change uh, whatever title we want to change to make more sense out of it. Uh, and then we replace our original data set with a new data set, and now we have all these titles of the uh, of the table, their number of siblings and spouses. That is what we changed it to, right? And now one more thing which might be of our interest is how many samples we have, how many passengers were there on that particular ship. I mean, how many data points we have for the passengers in this particular case. So if you just look at this height function, height uh, train, so it will give you uh, the number of samples that we have, and it turns out we have 891 samples with us in this particular data set, right? Uh, Now, moving on to the next point, that is, so we have access to data, and we have, so that was the first step, right? To have an access to data set. So we now have access to data set. The next step is pre-processing the data, cleaning the data that we have with us, right? So if I go back and just try to look at what type of data we have over there, maybe I can open it, this train data set that we have. uh, it looks something like this, similar to what we just saw, but here it shows all the samples. It has around 891 samples that we discussed. Uh, Now, if we look at here on the in particularly in the age column, and if I'm just scrolling down, there are some entries which are non, that is not a number, right? So we do not have information of the age of that particular passenger, where we all have this NaN thing. Right. So once if we have this sort of entries in the table, it sometimes makes difficult to process the data and perform some analysis on it, right? So we need to get rid of that and we need to make modifications and clean that particular data set that we have, right? So one way to do that is replace all the NaNs by the average value of other ages that we have, right? So this is the one way that you can do. Otherwise, you can just get rid of that by removing that particular data set, right? So this is a command which is nan min. What it does is it sort of takes average or the mean value of all the train dot age. So train dot age is the column that defines age. So it takes the average of the age excluding the NaN values, right? So it takes average of that, and in this line we are sort of setting that particular sample which has NaN value in the age. We are setting that particular value to the average value that we just calculated. Similarly, we are doing it for the test sample as well, right? So let me just do that. So we calculate the average age of the passengers, which comes out to be around 29 years or 30 years. And we now have replaced our data set with this new data set, where we replace the NaN values with this average age over there, right? What we can also do is we can plot if is there any missing value in the train data. And by plotting this, so this is the function image set that you can use that particular data, that particular information, and then try to see whether we have something, whether we can get some information out of it. So if you look at here, this graph, what it suggests is what is the feature that has missing values? It is probably the cabin value over here, right? So if you go back to this and look at this cabin vector, yes, it has some values which are which are not categorical in that sense, right? So that is where that is what we are getting over here. So just by looking at this, we can get some sort of initial idea on what is there in the data set. So this is basically exploring the data set that we have. We have some data, and we're trying to get a first sort of information out of it. right? So now once we know that this is the data that it looks like, and we have done some pre-processing on that. Let's move on. Let try to get some more information by performing or by visualizing the data in some more some other format as well, right? So let's try to plot a histogram of of one of the feature of the data set that we have with respect to the passengers who have not survived and who have survived. Let's say one of the feature is fare that we have, right? Ticket fare. So let's plot a histogram of the ticket fares of the passengers who have not survived, and let's see what do we get. And also let's do the same thing for the passengers who have survived, right? So this is how the histogram looks like for the passengers who have not survived, in terms of, I mean, particularly in terms of the fares that they have paid to get their ticket, right? Similarly, this is the histogram that we have for the passengers who have survived. Uh, based again, the feature here is again the same. That is the ticket fare that they have used. You see, if you look at both of these histograms, we don't see much of a difference, right? So we do have, I mean, what it means really is ticket fare is it actually is not a good feature to classify whether the passenger has survived or not, and that makes sense, right? I mean, it does not matter whether you have paid a lot of money to get your ticket, or you got a ticket at very low cost. It does not guarantee whether you will survive or not, right? So this is how the very basic level understanding that we can get just by looking at the histograms. But what also, I mean, what you can also uh, check is, maybe instead of looking at the ticket fare, maybe it will be a good idea to look at the sex of the passenger, like if these are the men or women, or male or female. Uh, let's look at what is there, what information can we get. So interestingly, it is found that there are sort of large number of females who have survived than the uh, than the uh, male passengers over here, right? So with this information, we can basically build a really simple model that if the passenger is female, it is survived. If the passenger is male, it is not survived. That's a very crude, and we know that it's not a foolproof model, but it's a basic understanding that we can get out of this data. And based on this understanding, we can probably build some more good or better model, right? So this is how initially you can explore data sets using visualization techniques that we have inside MATLAB. I will share this file with organizers, and you can try to do other things as well. Like you can try to plot histograms for other, particularly say age factor. So how age matters, whether age did really matter in the survival or non-survival of the passengers, and so on. You can play with this and uh, uh, try to get some more information out of it as well. Right. So, any questions on this before we move ahead, or any comments, any suggestions you have on this? I can wait for say 30 seconds to take some questions.
Thanks, Pranav. This is Amit. I don't see any questions
Yeah.
in the chat window at the moment, but I just wanted to point out a couple of things. So one is EDA, which is exploratory data analysis, is like Pranav demonstrated. It's very important as a first step before even trying to explore all the different types of models there are, right? So just by looking at this data, for example, you could make out that the simplest model, which is, are you female? If yes, then you've survived, right? That in itself would would give you greater than 70% accuracy, right? Which is not trivial, right? And so that you can use as a baseline, and then any other more complex model that you develop has to be at least as good as that baseline, right? If you use like a support vector machine or some really fancy model, but it doesn't give you this much accuracy, then you have a more complex model, but also have a worse accuracy, right? Which is not good. Doing exploratory data analysis to create a baseline is what is quite important. And there are several other functions, just like group stats and the histogram visualization. There are several other such functions that you can look up as well. Go ahead, Pranav.
Yeah, thank you, Amit. So yeah, as Amit mentioned, so these are the several other functions which are available in MATLAB that you can use for doing exploratory data analysis in that particular thing context, right? Okay, if we don't have any more questions, we can go to the next step on the data analytics workflow, and that is on the pre-processing and pre-processing data and developing the models itself. So what type of challenges we can have? We can have we can have a lack of data science expertise. That is the major challenge that we might face. Uh, then we need to perform some kind of feature extraction. So mainly getting useful information out of the data that we already have. So these are the challenges, and there are many different models that are available. So how do we tune those models? How do we validate those models and come up with the best model out of it? Uh, so this is always a challenge to data scientists. So we can have multiple options with us, but what is the best option out of it? So that is what we want to look at, right? So what MATLAB provides the application, the graphical user interface that you can use to develop your model, test your models, and develop your multiple models simultaneously, and test the models. It can automatically convert your model into automatic MATLAB code, which you can then also deploy into the hardware and so on, right? So these are all the benefits that MATLAB can provide in this particular point on the data analytics workflow. Right. So to get hands-on, I mean to get experience on that, let's look at another demo on the curve fitting, particularly on the stock price analysis. And we'll try. So in addition to writing the code, what we'll do is we'll actually go and use MATLAB app, which is there, developed by MathWorks, and we can try to get this thing. Uh, I mean, try to build a curve fitting model using that particular app, right? So let me go to that part here. I'll first close this and I'll clear everything. Yeah, so what we are going to do is let me show you this particular Excel sheet. So this is the Excel sheet that we have. This is a form of data that we have with us. I'll double click it and open it here. So this is how our data currently is looking like, and this is, as I said, this is Excel data. It opens in MATLAB and it looks similar to the exact version of the Excel, right? Almost like that. So we have these two sheets available here. The Amazon. So this is actually the data of Amazon. Amazon stock prices and Coca-Cola stock prices over here, right? So these are the stock prices ranging from, let me see here. So from 1997 to, I think, in what, 2019, we have recorded I mean, this data is taken from the Google itself, and we have the data of stock prices of Amazon and Coca-Cola from 1997 to 2019, right? Uh, yeah, so if you look at it, 1997, the Amazon stock price was really low, around $2, and so on. And now we know what Amazon has done. It has ranged a lot more in, say, around $2,000 and so on, right? So now what we want to do here is we want to analyze this sort of data and try to develop a model which can predict the stock price maybe after some time, or maybe predict based on the data that we have. Data we have only till 2019. Can we predict the stock price of Amazon today based on this particular data that we have? So this is the problem that we have with us. So now, as you saw here, I just double click on the data and we got this particular window open. We can now go to this import selection tab. If you just click on this the correct button, the data will be imported in a MATLAB and you can work on that data. What we can also do is we can create a generate live script out of it. I mean, whatever I did right now, I just double click on the data and we get to this particular tab or this particular pane. I can create a code for that as well. So automatically generate live script, and it will open a new live script where you see all these lines of code are now automatically created to import the data of the Excel sheet. Now, if you want to do some changes while importing itself, you can do that over here as well, right? Now I'll run this code, and we see now we do have imported the data set over here, right? So what type of data we have? We have the first column is date and the second column is Amazon closing price. Again, the very basic exploration of the data, the first step is to visualize that data. How does that data look like, right? So let's store these two columns into another two variables, and let's try to look at this. So I am creating this another variable named date, which will store this particular column over here. So what is the table that we have? It's AMZNKO. One advantage of working in MATLAB is, the live script is it will automatically fill in and give you some suggestions like this, right? So what column that we are going to look at? Amazon, sorry, AMZNKO dot date. So this will be now stored in this particular variable date, and say closing price. I'm giving this name to the Amazon closing price variable, and let's look at that particular column and store it in closing price over here, right? So we have now stored this data into two vectors, and now let's just plot these two vectors, right? So first one is date, second one is CP, and I'm just plotting this, running this particular command over here, and let's see. So yeah, we have this particular graph that pops up, which shows that this is how the Amazon closing price is varying with respect to date that we have, right? So this is what we have, and it looks like, yeah, Amazon price is sort of shooting up with years, or with date. What we want to do is we want to create some kind of model out of it, and then based on that model we want to predict what will be the closing price of the Amazon. Maybe we want to estimate the Amazon stock price today, right? So this is the problem that we have now. So for that, what is a basic what is a basic model that we can develop is the curve fitting model, right? We can fit a curve out of this and predict something over there, predict the Amazon price out of that, right? Now, for doing curve fitting, what we need to have is we need to have two vectors in a numeric form. Right now, if you see this date column is in some weird form, it has some numbers, it has some string, and so on. We need to convert this particular column into a numeric form, and then maybe you can use curve fitting toolbox over there. So let's do that. Let's convert date into numeric form, and it can be done in a very one line of code. That is a date num is the command we have, and we are converting our date column into numeric vector, right? And let's just try to plot this new date numeric date vector that we have with uh, uh, alongside with the closing price. And if you look at yeah, so the qualitatively the graphs will not change. The x-axis actually changes because now we have converted our x vector, that was a date. Earlier it was in a date format. Now we have converted it into a numeric format. So this is how it looks like, right? So once we have both of these vectors with us, numeric date and closing price, we now want to fit a curve over here. So instead of writing our own code on that, what we can actually do is we can go into this uh, uh, MATLAB interface. And if you look at the top, there is one tab called apps. So if you click on apps, there are already various inbuilt apps which are there, which are developed by MathWorks. So we can make use of these apps to perform various analysis. And also, if you want to create your own apps, you can do that by going into this design app thing, and those apps can be created very easily as well. You need not have to have a lot of coding background to do that. Particularly in this case, we are interested in this curve fitting app. So let's open this. I'm just clicking over here and let's look at the curve fitting app. It is opening, and this is how the window will open, right? What data we have? So on the x-axis, we have date. On the y-axis, we have closing price of the Amazon. And it gives us a really quick view of how the x-axis or the how the closing price vary with date, right? Now this is we are working inside the application, and if you so the black line is actually the closing price that we have, and the blue line here is a curve that is being fitted on this variation of the closing price. Right now, if you look at this is the polynomial fit is being done of degree 1. What it means is a straight line, right? Polynomial of degree 1 is nothing but a straight line. Uh, Obviously, it's not fitting the data really well, and that is also you can see on the left hand side there is there is measure of the goodness of fit, multiple measures. Out of that, you might be aware of the R square, that is zero point 0.5, which is not so great. A good model should have around the R square, which is closer to 1, maybe at least maybe greater than zero point 0.9 or so on. So this is definitely not a good fit, and it's also obvious by looking at the figure itself. So let's try to increase the degree of the polynomial. Maybe say make it degree 5. It is better, right? It's improved model over there. There. But it's also a little bit complex in terms of polynomial. We are getting R square value, which is really great. So this model might work, but the polynomial is getting really complex. So instead of polynomial, we can have a lot of other things as well. We can have say exponential thing, you can have Fourier series, you can have Gaussian. So if your data is sort of looking at like a bell curve, you can use Gaussian fit and so on. You can, so all these options are available. Right now we can see that the data sort of looks like exponential. So let's go to exponential, and the number of terms is 1. So the our equation will look like a exponential bx. So this is how the curve, the fitted curve will look like. It has R square value of 0.975. So this is sufficiently good, we might say. And this is how our model is now developed. So without writing any code, just by doing some scroll down option, hitting some scroll down options and so on, we have now created our own model with us. We have the model with us, right? Now you can go to file over here. You can of course save all these things, but importantly, what you can also do is you can generate a code out of it. So what we have not written any code, but you can generate a code automatically, and this code is now over here, right? So this is how, this is a function that is created. I'll just save this function here, maybe. Oh yeah, so me see, here it is. I'll save this here, and now we have the Amazon or the curve fitted with us. Can we sort of now predict? Can we make some predictions out of it? So I'm just using this function here, and maybe this I can rename is say x data. Say this is y data, and or let it we can keep it as it is, like this. We have this function with us now, uh, right? And I did run the code over here. So this code is what's automatically generated. I'm making use of that particular function to fit my own data over here, right? Now we have that data. Now let's try to predict the value, which is value of the Amazon price today, right? So let's see what is say let's do this x data is the date, or what we can have is date time now. So what it gives us is yeah, so it gives us a today's date and time, that is 14 December, and this is the time that we have. We need to convert that into numeric variable here again, right? So date num, the same thing that we did earlier, and I'm running it, and we get this numeric value over here. And now I'm just sort of running or getting this particular variable and trying to find out what is the Amazon price based on the fit based on the model that we have developed earlier, right? So we get this sort of answer, that is what is the today, what is the Amazon stock price today. It gives us the answer of say around what 3,353 and so on, right? Let's look at whether it is whether it is really the case. So let's see what is the Amazon stock price today. It's not, the prediction is not too bad, right? It's 3,100, and what we get is around 3,300 and so on. So it really is making sense. With whatever data we had, we created our model without actually writing too many lines of code, and we're getting approximately good set of results. Right. So what are the key takeaways? We have, I mean, we can, using the app particularly, we can interactively develop all these models very easily, right? Uh, so any questions till this point of time, particularly on this demo that we had, curve fitting? Anything, uh, any question or comments on this? I hope I'm making sense right now. If not, please do let me know.
Pranav, there are no specific questions in the chat window. I'm assuming that everything's making sense.
Yeah.
If any of you have questions, please do, like Pranav mentioned, interrupt us. Don't hesitate. Just let us know, and we'll try to address them immediately. Thank you.
Right. And yeah, so apart from that, so we have all these other functions which you can also make use of while doing this descriptive sort of analysis, right? Now, moving on to the next step, we are going to take a short break now. But before that, so once the model is developed, our aim is to sort of get we can then deploy this model into hardware, and in terms of apps, we can deploy these models and then make use of all these things later on as well for doing some prediction or for doing some decision making over there. And so this is the data analysis workflow. And again, the challenges could be there could be multiple challenges, like we need to deploy this to the end users who are end users can be of various types, operators, administrative staff, and customers, and so on. And MATLAB again provides you the solution in which you can deploy your models into enterprise level systems in terms of standalone applications or many other programming like C, C++ codes, and so on. You can convert that over there. Uh, you can deploy these models into embedded hardware as well. So the point is the entire workflow, data analytics workflow can be now done in MATLAB over here. So that is the advantage that MATLAB brings into. Uh, yeah, so we now know how data analysis can be done. We can build some models, but are all the models good? So this is sort of there is a concerned parent. Like if all of your friends are jumping off a bridge, would you follow them? And if I am being the machine learning algorithm, I'll say yes, right? So this is sort of the fact that we may create a lot of good models, and these models can be smart enough to perform some good tasks, but those models might not be intelligent enough to do that, right? So with this, we can take a short break, really short, maybe not of 10 minutes. We can take maybe 5 minutes break or something, and then we'll come back. Start move.
Yeah. Yeah. Thank you, Pranav. We have one announcement for participants. Renuka
Yep.
madam, would you like to make, or I'll make an announcement?
Anything will do, sir.
चलो आप ही कर दो.
So I think many of you might have come across this, that Gmail, YouTube, or Google Docs, all the services that Google is providing, they are hit by widespread outage. So due to that, we are not able to access the Google Forms by which we take the attendance come feedback form. We shared you the link, so that will not be provided. But what we are doing for that, so we will monitor the attendance manually. In fact, we have already monitored who are present for the today's session. So for today's evening session, there will be no link on the chat section.
Yeah. Thank you, Renuka madam. So we are not able to log into Google. You can check it out throughout. It is a widespread outage. So no Google login is available. No Google Docs. No YouTube. So you can check it out. So attendance is manually we will take. Thank you.
Sure. So I think it's 6:04 now. We can maybe get back at 6:10.
Yeah. 6:10
Sure.
minutes.
Fine. So I think it's 6:10 now. Should we wait or should we start now?
I think we should start.
Okay, fine, sure. So yeah, I hope everyone is back or most of you are back. Uh, so till now we saw on the basics of data analytics in the say in the form of curve fitting and exploratory data analysis and so on. Now let's get into the machine learning part itself, right? So what is machine learning? Again, it's the ability to learn from data without being explicitly programmed. So earlier, what we used to do is we used to model the things in terms of physical modeling or mathematical modeling and create equations out of it. And based on those equations, we used to write programs, right? Now, in machine learning, what happens is we have data. Now, even if we don't know what exactly is happening in terms of physical aspects, just by looking at the data and getting some information out of it, we can create good models, and we can make some predictions without being explicitly programmed through in the sense like even if we do not know any physical equations which are involved in that particular thing. And machine learning is almost sort of everywhere now, right? So the systems can be too complex to to model them physically. So the systems can be like speech recognition, object recognition, or engineering health monitoring. So you can see the systems are very complex, and those have very non-linear sort of relationships, which are non-linear relationships are involved in terms of physical components of those models, right? If we try to model them using equations, so it becomes very difficult to do in that sense. So uh, machine learning can help to analyze and make some predictions or decisions out of that. Uh, Sometimes what we can have, just like we did for the stock market prediction. So this stock market prediction or weather forecasting or energy load forecasting. So these are the continuously varying variables that we have. So the data will be updated continuously, and this data is available. More and more data is available. So how your models can change if you have multiple data. So that's where machine learning can also help in that context. Also, if we have large number of data sets with us, we can learn efficiently from very large data sets. The examples will include the taxi availability or the airline flight delays and so on, right? So this is how machine learning is sort of now in all these sort of domains, right? What are the types of machine learning? I'm sure you might have gone through all this. Just to give a quick recap. So we can have two types like unsupervised learning and supervised learning. In unsupervised learning, the major the problem set that we can deal with is the clustering, where we do not know what are the responses, but we only know how the data looks like, and based on only the data, the features that we have, we can sort of categorize into different clusters. Even though we do not know the names or the labels for that particular cluster, we can do that using unsupervised learning. In supervised learning, we can have classification, again two types, classification and regression. In classification is basically just a output is a choice between classes, right? With a plus minus, like true, false, or multiple classes, like number of colors and so on. In regression, however, it is the output is a real number, just like what we did for the stock prices. It is continuously varying number, and we can have those analysis which also come into the supervised learning thing. What we will look at in this limited amount of time is a classification problem today. Uh, the workflow remains the same. What is the workflow? As we said, access the data, pre-process the data, derive some information out of the data that we have. Based on that information, let's train the model, and then uh, we can iterate on the model that we have and try to bring out the best model out of it, whatever we have, and then finally integrate the model into a production system, deploy it into hardware and so on, right? As you might have gone through the classification, regression, and clustering, models can be of multiple types. Like in classification, we can have SVM, discriminant analysis, nearest neighbor, neural networks. In regression, there are multiple things. In clustering also, we can have different types of models with us, right? So what is a supervised learning workflow? Once we have data set, we will divide it into training set and test set, just like I described earlier. Once we divide that into training and test set, we will perform some analysis on training set and try to build a model out of it, right? So we will do some feature extraction. We'll do some, in this case, supervised learning. So we can build some classification or regression techniques and build a model out of it. In this case, particularly the classification model. And once we have this model, on the test set, we need to perform the feature extraction again, right? So we need to perform feature extraction on the test set as well. But instead of now building the model, we are directly using the model that we have developed earlier in the training set and now doing the predictions based on that, right? So this is a general workflow that we have in the supervised learning. uh, uh, and there are multiple classifications. So in this case particularly, we are looking at classification problem, right? So there are multiple classification algorithms that are there: support vector machine, knife based classifier, decision trees, and so on. We will go through one demo which will explain how you can deal with the classification problem over here, right? So let me go to MATLAB again. Let me just close this, right? So this is the problem that we are going to solve. Uh, so this is a classification problem. Uh, which is we will be working on the data set for the Fisher iris flower. So this is one type of flower, and it has number of species, particularly in this case, say 3 species, which are known as Setosa, versicolor, and virginica. These are the 3 species that we have, and based on whatever features that we can extract from those particular data set that we have for the Fisher iris flower, we want to classify these flowers into different species. So what are the features that we have in this case? We have petal length, petal width, uh, sepal length, and sepal width. So these are sort of marked in the image over here. Is a sepal length, width, petal length, and width, and so on. This data is available in this website. This file will be available to you, so you can go through this and get the access to that particular data. Now, so again, the first step is to load data, and then we will set up some features of the predictors. We'll set up some responses, and then finally we'll build a model out of it. So let's first load the data, what we have. So I'm loading this data. This data is now in the MATLAB. Let's look at, I'll just clear the workspace first and we'll do it again. So we have loaded this data into the MATLAB. This data looks something like this. So we have this maze variable over there, which is 150 by 4. So 150 rows and 4 columns. So specifically there, the first 2 columns deal with the petal. Let me see. Yeah, the first 2 columns deal with sepal length and width, and the last 2, third and fourth column deals with the petal length and width over there. So this is how the data looks like. And in the species variable over here, we have labels associated with the data set that we have. Uh, Labels in the sense we have the categories of species with us right now, right? So we will just go here, and what we will do is we will now only take predictors as petal length and petal width. Okay, so we already have this loaded data, and the third column of that is a petal length, fourth column of that is a petal width. So we are extracting that information and creating input feature matrix over here. So the first column will be petal length of that feature matrix. second will be of petal width, and the species, the responses will be stored in this particular variable y. So this is the pre-processing that we are doing. Just modifying the data, the extracting features, and assigning them into number of variables. Now, once we have this, now instead of writing a code and creating a model, that can also be done. But instead of doing that, what we will be doing is again similar to what we did for curve fitting problem. Using an app, we can go and open an app for classification problem over here. Right. So you can open the classification learner app with this command, or again you can go back to just a minute. I'm not sure. Yeah. So you can go back to your MATLAB window and apps tab over here, and you can look at the machine inside the machine learning and deep learning application sets. We have multiple applications which are available. Classification learner is there, regression learner is there, neural network designer is there, and so on. Out of which we will be now using classification learner. So once this app opens up, what we will do is, this is how the window looks like. Let it come up. Yeah. So we will start a new session here, and in the session, what we are going to do here. So if you look at in the workspace that we run the after running the code, we now have petal length, petal width. We have x vector which has both petal length and petal width as their column, and y is the response variable that we have, right? So inside the application, we will select inputs as the x variable, right? Because x has both petal length and petal width. And in responses, I can from the workspace, I can select the responses as the y vector, which is a categorical form. So now predictors are column 1 and column 2 of x that we have given, uh, and we have the response over here stored in y, right? So now, as we said, we can perform some. I mean, we have separated the training data set, and we have to segregate the data set into training and test set. That we can do using this validation, number of validation techniques. So if we do not validate, what it means is we are using entire data set as a training data set. If we do hold out validation, what it means is we can set up 25% of our data sets as a test set or the validation set, and use 75% of data to training. In the cross validation, you can select the number of folds. Like we can divide our entire data set into, in this case, say 5 folds, 5 buckets for that, just to give an idea. And we will use one of that particular bucket as a test set, uh, and other 4 as a training set. And we will iterate this process continue for all the 5 sets, and get the better model out of it. So different validation techniques that can be performed, that can be used. Let's use this cross validation technique with say 10 folds for now, and let's start the session. Uh, Once we do that, yeah, in this window, we now have our data points, right? So in this case, you see the scatter plot function is the tab is there. This is automatically gives you the scatter plot with the predictors that you have with you, right? So the predictors, in this case, we have only 2 predictors, petal length and petal width. You can have multiple of those, and just for visual inspection, you can then look at how data is scattered in terms of different predictors. You can select on the x-axis, you can select any of the column. On the y-axis, you can select any other column, and try to look at how our data looks like. So in this case, you can see the blue points which correspond to the Setosa species. These are clearly classifiable. I mean, these are far away from the other 2 species. There seems to be some overlap between versicolor and virginica, right? So this is how the data looks like. Now, once we have this data, we now want to create the classification model out of it. So if you go in this uh, tab on the top, we have multiple models which we can build out of it. So we can have decision trees. Again, in decision trees, you have multiple fine trees, medium trees, coarse tree, and so on. You can have knife-based classifiers. You can have SVM. Uh, Here, SVM is there. So linear SVM, cubic SVM. So all the models are there. We just have to select which model we want to do. Or if you're not sure which model will perform better, what we can also do is we can sort of just click all the models, and we can simultaneously train all the models based on the data that we have. For that, we have this parallel computing toolbox, parallel computing pool, parallel pool that we can open up, and it can simultaneously simultaneously train all the models and try to get output of that. So let's just click on train button. So now the parallel pool is opening up. It takes a little bit of time. Once it opens up, you can see your data is being trained really quickly on all the models. Let's wait for maybe 5-10 seconds. It will open up now.
While this is running, this is Amit. Just a quick couple of points I'd like to make. So one is you may have noticed Pranav chose only two features, right? So the original data set had four, petal length, petal width, sepal length, and sepal width, but he chose only two, right? That at some level is something called feature selection, right? We did it seemingly randomly, but you can, if you so choose, do it more intelligently. For example, in the Titanic survival data set, choosing the gender or the sex versus choosing name, right? Gender is obviously a more useful parameter than name, right? So that's something to think about as well. So I'll let Pranav continue now that training started.
Yeah, sure. Thanks, Amit. So you see now, parallelly, multiple models are being trained over here, right? Because we now have parallel pool open. So all the models are being trained simultaneously, and it does not take a lot of time as well. So let's look at here, and we have this particular model, which gives very good the maximum accuracy, like quadratic discriminant model over here. It gives around 97.3% of the accuracy, right? So this is how, if you're not sure which model might fit well, you can always go and select all, or if you have some idea like which model might fit well, you can go and select that particular set of. So for example, if you know that SVM might perform better, then you can train all SVMs together and just try to get some information out of it and get the best model out of whatever models we have. So for now, it seems quadratic discriminant model is performing really good. Gives around 97.3% of accuracy. What you can do is go to the confusion matrix and look at how does it perform, right? So here again, we have true class and predicted class. So as we saw in the visual scatter plot as well, the Setosa are species are quite far away, and there should not be any confusion for predicting Setosa here. So we do not have any the cross diagonal terms for the Setosa term, Setosa species, but for others there is some misclassification over there. Particularly, like we have some overlap over here, and these are the three species which are incorrectly classified. You can see over here. So this is how we can get we can analyze our model that we have developed as well. Uh, yeah, and as Amit mentioned, in the feature selection, right now we have only two columns. But if we have multiple columns, we can choose whichever features you want and train your model particularly based on that. Or there are feature dimensionality reduction techniques such as PCA, principal component analysis, that also you can apply onto your data sets or the features that you have, and you can train the models based on that as well. Now, once you have this model built, now we know that this particular model is behaving well or behaving best. We can then sort of export this model, this particular model from here, and you can either generate a function out of it. Again, the automatically generated function will look something like this. Or what you can also do is you can export this model into the workspace. So you can give whatever name you want to give for that particular model, and it will appear in the workspace like this. So this is a trained model, and you can predict you can make predictions based on using this particular command. So trained model is a model that we have trained right now, and we can make some predictions. If we know what are the petal length and width, you can get a prediction over there, right? So this is how, again, without writing too many lines of code, you can actually perform the classification. And also similar process workflow goes for the regression analysis as well. So we're not going to that right now, but this is how you can do. So all these different models, MathWorks supports all these different models as well over there, right? So
So now, if I can
yeah,
add something very quickly, sorry for
yeah,
interrupting
sure,
you. If you go
yeah,
back to the app, uh, this is possibly also something that will be interesting to a lot of you. If you open the model type drop down, right, you may
yeah,
notice there are a few other types at the end called optimizable tree, optimizable discriminant, optimizable
yeah,
naive Bayes, and so on, right? So the way we've shown this to you may appear like, it's just clicking a few buttons and then getting things done, right? However, there's a lot more that happens under the hood, okay? Particularly each of these models, they have some parameters called hyperparameters, right? They're specific ways you can tweak your model so that they perform better, okay? For example, the tree models, there are several parameters that you can set up to make the tree build itself differently, right? Now, how do you choose these parameters is a difficult question, right? And that is why the optimizable tree option comes in. So what it really does, very briefly, given that we don't have very much time, is that it optimizes these hyperparameters also automatically, okay? Meaning that really you don't have to do anything to modify the model itself. All of these properties are taken care of for you, and it in fact does this thing called Bayesian optimization, right? So there are several. In fact, there are three specific. There's grid search, there is Bayesian optimization, and then there is random search. And in fact, this particular option does Bayesian optimization, which is great, right? So that's another. If you're looking for ways to do hyperparameter tuning, the app can do that. And mind you, this is specifically in the machine learning world. In the deep learning world, there's a separate kind of series of steps for hyperparameter tuning. We have an app called the experiment manager for that. But if you have questions on that, we can look at that later. But I just thought I'll bring this up at the moment. Thanks, Pranav. I think there's a question about checking how to check if the model overfits or underfits.
yeah. So would you like to take that, Amit?
Sure, I'll try,
Yeah,
and you can add later on, Pranav, if you'd
yeah,
like to.
sure.
So the question is how to check if the model has overfit or not, right? So this is exactly where the splitting of your data sets comes into the picture, right? So if your model performs very well on the training data set, right, the data set that you've used to tweak its parameters on, but it performs quite badly on the test data set. Or even when you're training, if you want to track it, if it performs badly on the validation data set, then it's an indicator that your model has overfit, right? Now, if you don't split your data set in the first place at all, and if you only have everything that you have in your training data, then you can't even test. You don't even know how it performs on new data, right? So in that case, you can't even measure that you overfit, right? And that is why it's important to split the two. The intuitive way to think about this is your training data set is kind of like as faculty, you teach students concepts in your class, right? So think of that as giving your students some training data every now and then so that they learn from it. Now, in the final exam at the end of the semester, that is where you use the test set, meaning that is where you ask these questions that you may never have asked them before, right? Now, if the students perform well in the final exam, then it means that they haven't bounded anything, they haven't memorized things, and hence there is no overfitting. However, if they perform badly in the final exam, but their training accuracy is good, meaning that they can memorize things, that is a measure of overfitting. Underfitting is something that I have not come across very often. Essentially, what that means is that your model is not powerful enough to represent or to describe your data distribution, right? That's a much more difficult thing to measure. And typically in the kind of models that we use these days, they are all fairly descriptive and have enough representational power to not underfit. Okay. One situation of underfitting, for example, is if you use a linear model, but you know your data is nonlinear, right? Then there is, as much as you train it, the best it can give you is a linear output, right? That's an example of underfitting. Now, how do you track that or check that? That will depend again on your EDA, right? If you do your exploratory data analysis well enough, and if you understand your data distribution well enough, you can then say, okay, linear models in this case do not work, so I need a nonlinear boundary. In fact, the next example that Pranav will show you will cover a little bit of what these decision boundaries look like and so on. So hopefully that'll answer your question. Sorry, I took a little longer than I imagined, but Pranav, do you want to add something?
No, I think that's great. So that's exactly why we did the validation part as well, right? So if we do no validation, it says here like we do not have any protection against overfitting. If we do some cross validation, we have it protects against overfitting by partitioning data sets into number of folds and so on. So that's where validation and separating the data set into training and test parts come into picture, and that is important in that sense to avoid overfitting and so on, right? So yeah, that is it from that point. Uh, yeah, now let's move on to the another demonstration, and this is regarding the visualization of decision boundaries. So uh, we have multiple models with us, but how those different models work and how those models behave. So what are decision surfaces? Decision surfaces are the boundaries which actually classifies different things. So let me directly go to the demo over here, which is this one. uh, yeah, let's see. Sure. So this is again the same example that we are using for the classification of Fisher iris flower, uh, and here we are loading the data set, and instead of going with the petal length and petal width that we did in the earlier case for the classification for building the classification learner, instead of that let's look at the sepal length and width now, which were the first and second column of the data set that we had. uh, Everything else remains the same. Let me run this. So we now have all this data stored in the workspace, and let's try to again visualize the data using scatter plot. So instead of doing that in the application, we're now doing it in the live script environment, where we are actually writing a code to plot the scatter diagram over here, right? So let's look at how this data looks like. Uh, yeah, it looks something like this, right? So we have Setosa species which are in the red color, Virginica in the blue color, and the square, the green color are the versicolor which are here. And if you look at the algorithm that has been developed, that was used, the knife-based algorithm. Okay, let me come down here. So we have let's try to compare decision boundaries for different algorithms. So we have knife-based algorithm, and we have the classification tree, that is another algorithm to classify the model. Let's build both the models, the knife-based model as well as classification tree model. So this we are doing using the line of code instead of doing it in the application now. So this model will be stored in this classifier. The first cell and the second cell is the classification tree model. This is there, and now what we are doing is, say we create a mesh of the grid on the x-axis and the y-axis on the multiple uh, of the large resolution. Particularly, like, so this is the first one, the first column of the vector we had was a sepal length, another one was a sepal width. So we are creating a mesh grid out of all those sepal length and width that we have, and we are now predicting the responses based on whatever algorithm that we have designed using knife base in the first case. In the second case, it was classification tree. So we will predict the species over this entire mesh grid, and then let's try to plot those things, and let's look at how the do they look like. So you see here the red part, the red the red color shows a Setosa species, green is versicolor, and blue is Virginica species. And you see here the knife-based algorithm is sort of giving you a smooth boundary surfaces, so smooth decision boundaries, whereas classification trees are giving you sort of some kind of a box type of boundaries, right? So classification tree is actually trying to sort of create, I don't know whether we'll call it as overfitting. It tries to capture the more information, but again, the boundaries are not so smooth. So what it basically does is it just creates a logical based type of algorithm. algorithm. Like if you have the sepal length, which is lying within this range, and sepal width, which is lying within this particular range, then it is a Virginica, otherwise it is something else, and so on. So we have the sharp box type decision boundaries with the classification tree algorithm. And in knife base, instead, we have smooth boundaries, which so by looking at these decision boundaries, we can possibly also look at whether our model is good enough to generalize and predict things and so on, right? So this is how you can visualize the classification boundaries as well, and try to get some more information on that. Amit, would you like to add something on this point here?
Yep. So thank you, Pranav.
Yep.
Just to reiterate, right? Um, what we're trying to demonstrate here is that you may have a question. For example, if you go through the app, the classification learner app, and then you may just choose one of the, you may choose run all, and then you may find that certain algorithms or certain types of models perform better than others, right? And the question is why, right? So we're trying to demonstrate why these methods behave differently from each other and what their limitations or advantages are. If you take the example of classification tree specifically, right? If you look at that sort of vertical line along the at x equals 7, if you look at that vertical green line, that is an indicator of overfitting, right? The reason is that if you scroll up a little bit, Pranav, and look at the original data points, right, on the right-hand side curve, right-hand side graph, you'll notice that there is one green point between 3 and 3.5 along the y, and x equals 7 exactly, which is what is causing this model to think that every point along that vertical line has to be green, right? Has to be versicolor. This is this is what overfitting looks like, right? If you look at the nice base model as a comparison, it's a lot smoother and it's a lot simpler in terms of the interpretation, right? So what may be happening here is because we only have 150 samples to begin with, the classification tree, what it's doing is it's trying to learn as much as it can from those samples. Now, if we add another 150 samples, let's say, the boundaries may look very different for classification tree, but naive Bayes might remain the same, right? So that's kind of like the analysis that you can do to really understand how these models behave. In fact, there is a lot of very interesting philosophical connotations of this. There's this particular thing called Occam's razor, right? So the idea is really the simplest explanation for any phenomenon there is most likely the right explanation, right? So you may have heard of these things called regularization methods, where you don't want too many parameters in your model. You don't want too many things, too many variables explaining your system, right? And to reduce the number of these parameters, you use things like L1 regularization and so on, where you try to minimize the number of terms in your model parameters. The whole theory around it is called, like the philosophical understanding of it is called Occam's razor. So please, if you're interested in this kind of work, do try to Google this. And now that Google services are running, try to Google Occam's razor and find out what it looks like. It's very interesting as well. So that's it for now. I know there's not much time, so I'll stop there.
Yeah, sure. Thank you. Thanks, Amit. So this is how we can do the visualization of decision surfaces as well. Yes, so in the interest of time, I'm not sure. So Amit, would you like to go through this demo on dealing with the large data sets?
Yeah, so it's 6:48 and we end at 7. So why don't I just very quickly, for 5 minutes, walk you through very briefly how to handle things like this, and then we can reserve the rest of the 7 minutes for questions. How does that sound?
Yeah, sure. I think it should work. Would you like to
Cool.
share your screen?
Yes. Would you mind passing me the presenter privilege?
Yeah, actually.
All right. Thank you. So let me share my screen now. Okay. So give me a moment. Share screen 1. Okay. Hopefully you can see my screen now. If not, let me.
Yeah, it's up.
But great, thank you. So I'll not spend very much time here, but I'll try to focus on the specific parts of this live script to demonstrate how to work with a lot of data here. Okay. So big data obviously means a lot of data, and with a lot of machine learning and particularly deep learning methods these days, the dependence on the amount of data you need to train has increased a lot. Okay, and so working with big data becomes that much more important. What is big data? The traditional definition of big data: data that can't fit in your memory all at once. Okay. For this particular demonstration, though, what we'll do is we'll try to show you how this kind of looks like with a smaller representative data set, but you can run this on literally terabytes or TBs of data, multiple gigabytes of data, and it should still work. Okay. So the problem here is we have some data from and this is about taxi fares and how much tip they are paid. Okay, the taxi cab people, how much tip they are paid. These days with Ola and Uber and things like that, maybe things are very different. But this data set comes from the city of New York here. Okay, so that's the citation there. So you may have heard of these frameworks called Spark and Hadoop. You can run these on those frameworks as well. But since I don't have it set up on my computer, I'll just I'll set this to fall my own laptop here since we're all at home, stuck without good hardware, I guess. So what we're doing is we are specifying the location of some CSV files. Okay, CSV files are essentially comma-separated variable files, and so this is all of these files here, the taxi data files here. So these are the let me open one of them to show you how they look in Excel. So they look at regular as you can the trip distance, longitude, latitude, they started, time of pickup, time of drop, and so on. And this is a lot of data, right? So I'm scrolling quite a bit, but still you see there's so much more. And I can scroll all the way down. I think this is 160,000 samples here in one file. And then there are 12 files like this. So this is sort of a representation of what we mean by big data. Okay? Now, what you can do is we have this data structure called a data store. Okay. So the idea is these data stores make it easy to handle replace this. Sorry. Give me a moment. I'm going to open the Explorer. So I'm going to the parent folder so that it can see these files, and then it should work now. So right. So what the data store does is it looks at this file location and picks up all of these files at once. Okay. It's intelligent in a way that we can create these things called tall arrays out of these data stores so that you can work with it even when it's not loaded in memory. Okay. So this is exactly what big data, the definition is, out of memory data, right? The data store you can, let me just quickly show you what it looks like. So you can think of it as if you've done C++ programming, this is exactly what references are, right? Or pointers are. So we are pointing to these files here, but we're not loading it in memory at all times, right? So we load on demand in some sense. So we do beyond that, whatever Pranav showed you earlier, right? Creating tables out of it and manipulating the column names and cleaning up the values. All of that is the same process as otherwise, right? So when we create this tall array here, notice that it will again try to open the parallel pool so that it can run parallel processing algorithms on it if and when required. But it treats this as it is one table, but really there is several rows that it doesn't load all at once, right? In fact, it calls it an M by 7 table because it doesn't really know what M is. M is a really large number. Okay. In the interest of time, again, I'm just going to proceed where we just whatever other manipulation that Pranav showed earlier, right, in terms of modifying the data type, for example, or creating new categories and so on, all of that you can do on this M by 7 or M by 8 table, just like otherwise. So the advantage again is you can explore and create your modeling algorithm of your data, for example. Imagine you got 100 more files to work with, right? The amount of change you have to make in your code to work with those 200 files is very small, okay? You just have to create this tall table out of your actual data store, and that's it, right? Everything else should work exactly the same as earlier. You don't need to learn parallel programming and things of that nature. You don't even need to learn Spark and Hadoop and things like that, right? It should be fairly straightforward to continue all your analysis in MATLAB itself. Now, this particular demo, which we can share this with you later on, really does a bunch of other things where it removes outliers. You can experiment with a subset of data, run some summary statistics and so on. In the interest of time, I'm just going to skip through it. But pretty much like what we did with the Titanic data set, you can draw plots around it and explore results and visualize what the trends are, the fare per minute is over different times of the day and so on. You can do all of this exploratory analysis on all of that data all at once, right? Without even knowing that there are so many data points in the backend, because the code here is exactly the same as otherwise, right? So that was the quick thing that I wanted to show you in the time that we had. We'll share this with you, and then hopefully you can run it on your own and learn more later. But this is all that I had to show. Pranav, can I pass the
Yeah, sure, Amit. You can do that. Yeah,
uh,
yeah, we are sort of wrapping up. Yeah,
uh,
thank you. Thanks, Amit. So, yeah, I think we are at the end of the session almost. So, the key takeaway is like machine learning is really everywhere. Amit? Yeah,
you should
yeah, sure. Is my screen visible?
a little longer than I would have.
Okay, I'm not
Yep,
sure.
yes,
Okay, yeah, sure.
coming up.
So,
Not yet.
yeah, right. So we are sort of at the end of the session. And so almost the machine learning is everywhere, as we saw in maybe automobile industry, industrial automation, aero, defense, energy, finance, and everywhere. And so these are the different champion companies that are working in all those sectors. And the MATLAB can provide you in a sort of basic framework which covers entire workflow to deal with data science and machine learning. Right? These are a few more resources that we can that you can go through and you can use. There is one good course on the course era on dealing with the practical data science using MATLAB, so you can go through that. And also, as I mentioned, there are on-ramp courses which are free available for everyone. Once you create your MathWorks account, you can go through this. This is a self-paced online course. I mean, it's just a 2 hour course, but it will give you good idea of what is there and how you can do machine learning using MATLAB. And the best part is also you can get a certificate after completion as well from MathWorks. And these are further, these are also a few more resources that, so after sharing the slides with you, we can go through all of this. Yeah, that's it. That is what we had. We can use remaining time for the question to answer a few of the questions. Uh, Amit has posted, I think, the feedback form in the chat window from MathWorks. So please fill out that feedback form so that we can get to know your interests, and then afterwards we can get in touch with you as well. And also feel free to know whether we can improve in some of the presentations and all that stuff as well. Right, so these are our email IDs over here. You can get in touch with us afterwards as well if you plan to work with MATLAB on the machine learning part. We'll be happy to get in touch with you and work with you. Now I open it for question answer session. If anyone has any questions, we can take that, or any suggestions, comments are also welcome.
Participants' question. If any doubts you have. Sir, this is an online editor. In that also these toolboxes are accessible, no? Data science related toolboxes.
Yes, I mean, you mean MATLAB Online, right?
Yeah.
Yeah. In MATLAB Online as well, you have access to machine learning toolboxes and data science toolboxes.
Achha, because there are few which are not accessible in online.
Yeah, no, basic data science and machine learning are there, so that should not be a problem.
That should not.
Anything else?
So I think no questions, I suppose.
Yeah. All
Okay,
right. So
anyways,
please, sure. Yeah, please feel free to
Questions at
give
this
your
point in
feedback
time,
on the feedback form.
yeah, no, it's perfectly fine to not have questions. Are
Yeah. I'll also paste those emails in chat window as well. So you can reach out to us later on as well, as Amit said, and we'll be happy to get in touch with you and work with you on that. So thank you once again for joining. Over to you, Surendra sir.
Yeah.
Pranav
Renuka
sir, while
madam.
that form, we are getting one error. At the question number 3, could you please share your email address? And it is saying that the value must be a number. So can you please check that so that we can submit the forms as well?
Okay, let me. Amit, are you there? Uh, let me see.
Okay. Meantime, Sunil.
let me look.
Yeah, it is there.
Please, sorry about that. No,
Yeah.
okay.
So can we conclude the session then?
Yeah, Renuka madam, you go ahead.
Yeah. So Mr. Amit and Mr. Pranav, thank you so much for the interactive session with excellent teamwork. Now we know how we can use the MATLAB for data science to how we can use MATLAB for data science. So thank you once again for covering the topics along with the demonstration on exploratory data analysis, building simple curve fitting models, machine learning, and more. Comparing models by viewing their decision surface, exploring model and choices graphically, working with large data sets and challenges. So thank you once again. Thank you so much for showcasing us the use of MATLAB for data science. So please accept this virtual memento from the organizing committee.
Thank you, ma'am. Thank you, sir. Thank you everyone for participating.
Thank you so much.
So thanks Amay, and thanks Pranav, and give our thanks to Alok also, Alok Bhatt and Amit Dage.
Yeah, yeah,
Because of
sure.
them, because of them we are able to connect you, and Alok has done a really good job for us. He had given us a MATLAB when pandemic started, almost for 6 months free uses of campus license, and he also informed us that S.P.I.T is the at the country level. If you see national level, if you see we have maximum utilized that license, our students and faculty members during that pandemic. He has a statistics, so say thanks to him
Yeah,
from
definitely.
our side. Yeah.
Yeah,
So, and thank you very much, and pass on the information, that is PPTs etc., that you were telling to the participants, so that I can pass on to them.
yeah,
And thanks a
sure.
lot. Thank you very much. Okay, and we will fill up this feedback form. So participants, please fill up the feedback form which they have shared. So I'll keep the Meet open for 5 minutes so that you can click on the link and complete it. Otherwise, our session is over. It's over for the day. Thank you very much.
Thank you.
Thank you. Thanks.